Okay, so the Milky Way galaxy is described as a disk of stars orbiting a central point on the disk. Something like this. Which of these best describes why people on Earth cannot see the entire shape of the Milky Way galaxy? Well, our sun is located kind of on a little bit further out of than this middle of one of those arms, and we have not gone past our moon. We've gone to no other planets. These are such vast distances that we have not gone far enough. And it's like when you take a selfie of yourself, you have to extend your arms and get away from your face. We cannot get far enough away from our own galaxy in order to take a good picture of ourselves, so we can just see what other galaxies look like and what we can see in our night sky and assume we are part of a spiral-shaped galaxy. Number 2, the Hertzsprung-Russell diagram shows how the sun is classified among the stars. So when it comes to this Hertzsprung-Russell diagram, we have these are our brightest stars are at the top, our dim stars are at the bottom, our hot stars are on the left, and our cooler stars are on the right. What type of star is several times brighter than our sun with a temperature of 3,000 degrees? Well, here's our sun, so we know we're somewhere up here, okay? 3,000 degrees, somewhere around here, but several times brighter, so that brings us with either the supergiants or the giants. If we look at our options, supergiant is an option. Main sequence, the part of the main sequence would be actually dimmer than the sun. The black dwarf, there's no such thing, and the white dwarf is also very dim. So the correct answer is going to be supergiant. Number 3, which source of energy is most responsible for weather and currents? Well, guys, the reason that we have weather and currents is because there are differences in temperatures. Anytime you have even the slightest bit of differences in temperatures, then you have a convection current where warm things rise and cold things fall. And that makes things move, not just air, but also water. So what causes a difference in temperatures? That is our sun, only our sun. Sun is usually always the answer when it comes to source of energy. So number 4, with the use of the Hubble Space Telescope, scientists recently discovered a giant runaway star. It is 90 times larger than the sun. It is very hot and blue-white in color. So this has to do with the temperature. It is much, much bigger, so it's a giant star. Why does the sun appear to be brighter than this runaway star when viewed from Earth? So our sun, so the sun is a different color than the runaway star. That is true. Yes, yellow is brighter, is a different color than the blue, white. That is true, but that really has nothing to do with the fact that it's brighter, that our sun is brighter. The sun is older than the runaway star. It's possible because, who knows? I mean, it doesn't, that may not have anything to do with it either. The sun is closer to Earth than the runaway star. The sun is the closest star to Earth. That's why it's our sun. That's why it's our star. We just named it sun. And then the sun is made of different elements than the runaway star. All stars are made up of hydrogen and helium, and that's it. Number 5. So we're looking at, based on this Hertzsprung-Russell diagram, which type of stars would belong to spectral class K. Again, we've got our bright stars up here, our dim stars over here, our hot stars, and our cool stars. I always like to do this on a Hertz HR diagram. So we're looking at spectral class A, only here. Has a luminosity of 10 to the negative 2. So we come over here. Usually luminosity is on the other side, but it doesn't really matter. So we're looking right here. This is where we're looking. So this is part of the giants. I would say supergiants would be 10 to the negative 4, so definitely there. So this would be 10 to the negative 2. The main sequence right here is 10 to the negative sorry, 10 to the second on that other one. This is 10 to the negative 2, and then white dwarfs are not even in the picture, so the correct answer is going to be giant stars. Okay, number 6, we've seen this one a couple of times. 4 students were asked to describe a nebula and a star, so which one is correct? So I'm just going to go through each one of them. For a nebula, student 1 says a collection of hot gases that sometimes produces light, so that is wrong. Okay, that is a star. So I'm going to just keep going. Student 2, a collection of hot gases that results from stars that have exploded. We're really looking at, this is okay maybe, because yes, when stars explode, they do turn back into gas and dust, and they can result in new stars, but we're really looking for a cloud of dust and gas. That's kind of the big point of that. So number 3, student 3, a collection of dust and gases, we're good, that form stars. They are stellar nurseries or results from dying stars, like I said before. So I like this one. I'm going to go over here to the star. A sphere of matter, definitely yes, with a density and temperature great enough to cause nuclear reactions at its center. I like that one too. This one over here, I can just easily see this says no light. That's not true. So the correct answer is going to be student 3C. Number 7, 2 regions in approximately the same latitude or distance from the equator can have very different weather. For example, Florida and California. So we've got Florida here, and then you're going to kind of go California over here. So pretty much close to the same type of latitude. So we can't really say that one is that much closer to the equator than the other. But why is Florida's weather so much warmer than California? Well, back when we were doing our weather unit, we talked about ocean currents. And one of the neat things about ocean currents is that here in the Pacific Ocean, we've got a cold ocean current coming down from the poles, which makes all of California's coast and water oceans very, very cold. It's super refreshing. Sometimes you have to even wear a wetsuit in order to get into it, that's depending on the time of year. However, over here, we've got the Gulf Stream coming up over here. This is the Gulf Stream that comes over here through Texas as well. But the Gulf Stream is coming up from the equator and is very, very warm. With it brings warmer air. That warmer air brings moisture. That's why there's also a lot of thunderstorms or rainstorms in Florida. Versus in California, it's very, very dry. Think about the wildfires that happen there because they don't get a lot of rain because they've got that cold current coming through, which brings cool, dry air. All right, the Big Bang Theory suggests our universe formed as the result of a huge explosion that sent all existing matter flying outward from one single point. So here was that single point. There was enough, they believe that there was enough pressure inside that it just sent everything out like that. The Big Bang Theory is supported by which of these observations? So what are we seeing? A, all matter in the universe is composed of the same atoms. Well, I don't think so, but yeah, because we know there's hydrogen and helium and there's all kinds of atoms out there. So B, all galaxies appear to be moving away from other galaxies. We do see that. We see that as things that are red shifting. So red shifting. All stars in the universe are approximately the same age. That's definitely not true. We have old stars, new stars. Those are the different stages. White dwarfs, red giants, all these are different ages of stars. And D, the universe is relatively the same temperature in all locations. Definitely not. We have all kinds of different stars and temperatures, colors happening in there. Number 9, which of the following best describes the position of the sun relative to other objects in space? So our sun is our sun. This is our star. This is our star for Earth. It is farther from Earth than any other star? No. In fact, it's closest to Earth. Is it near the edge of the Milky Way galaxy? So we've done this. We are kind of in the middle of one of these arms, closer to the edge. We are definitely not in the middle. Are we halfway between Mercury and Pluto? That's only within our own solar system. Own solar system, and that's not even true. They orbit us. Here's our sun, and they orbit us. So there's Mercury. That other one can be Pluto. Is it just outside of our galaxy? No, it's within our own galaxy, near the edge. Number 10, astronomers make observations in visible light, because that's all we can see. All we can see is visible light. That's sight. But also in other parts of the electromagnetic spectrum, such as radio and gamma rays. Scientists make observation in different wavelengths because, A, the information provided by visible light is not a reliable source of data. Well, I don't think that it's not reliable. It's, what we can see, but that's not enough, okay? It's just not enough. We need to see more. Observations in different wavelengths provide different information about stars. Absolutely. X-rays can see certain things, maybe the composition, where gamma rays will show something else. And so different, all across microwave, radio waves, all show different information about a star or galaxy. The equipment required for observation in other wavelengths is expensive, probably, but that shouldn't stop us, not in the name of science. Or D, visible light only provides information about the closest objects in our galaxy. Well, that is true, but the answer is, why do we use it? Because this is why. Because observations in different wavelengths give us more information. All observable objects outside our galaxy, when viewed from Earth, have their spectra shifted to slightly longer wavelengths. That's this. Astronomers have concluded that this evidence that all objects in the universe this is moving away from each other. That is that red shift. I'm going to have to go a little bit faster here because I'm running out of time. Which of the following best describes the relative distance of the sun and other stars to the Earth? Well, we've kind of gone through this a lot already. No other stars are closer to Earth than our sun. This is why this is our beautiful sun. The North Star is not closer, otherwise we would be able to, feel the thing off of our North Star, off of the sun, off the North Star. The only thing we can do with that is tell where North is. Okay, it says, which of these describes the star Spica? So Spica is over here. We already know that just because from where it is, it's very hot, it's very bright, and we can tell that it is on the main sequence, so it's an average to medium-sized star. Average to medium-sized. So over here, very small, it's average, so it's not very small. That would be a dwarf. Medium-sized, okay, I like. Relatively dim? No, it is bright. A yellow star? No. The fact that it's all the way at 30,000 degrees tells us that it should be blue. Is it blue? Yes. Is it bright? Absolutely. Main sequence? D is my answer. So this table tells us information on 4 stars collected by astronomers on Earth. Which of the stars is moving towards us? So we're looking at things towards us. We learned that when the electromagnetic spectrum when things move towards us, they start to bunch up. So they start to, what we bunch up like that, that is towards the blue side of that spectrum. So we call that blue shifting. It is red shifting, that means that it's moving away. Okay. So we're looking for blue shift. So we come through here, this is red shift, that's away, 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 and towards. So we're looking at, this one is the only one that is moving towards us because it is blue shifting. And then last, number 15, the spectrum for visible wavelengths is emitted by star X. That is compared to 4 different elements: hydrogen, carbon, neon, and magnesium. Which of the element is present in star X? So in order to find out where they're present, they have to match. So all of these here match. This one matches that one, this one matches that one, this one matches that one. So all of those little lines in hydrogen match. These do not. So there is wrong. Here, this one does not match, is wrong. This one does not match. The correct answer is going to be A, hydrogen. Hope you guys have a better understanding about this. Please make sure you turn this in to your science teacher by